Hello and welcome to this tutorial. So here we will be making a PCB for our current sensor, which is LTS 25NP. As explained in our blog text, we are going to use this specific current transducer because it gives a lot of learning about how to make a PCB layout in a software. So my software is DipTrace, where I am going to make the traces for an LTS 25NP current sensor. I have explained that for this purpose I have to use a 7805, which is a regular TO220 package available, positive voltage regulator. I need some connectors to connect the biasing voltage power supply as well as the input and the outputs, and I am going to use the LTS25NP sensor. Now the reason why I have used it because this sensor is not available in this component library. As you can see, there are a lot of libraries here. But LEM has no library for the components, therefore we have to make it according to the data dimensions given in the data sheet. So if you open the data sheet of the LEM transducer LTS25NP, on the last page you can see that the dimensions are given in millimeter. So if you don't see here in millimeter, if it is in inches, you can convert using this DipTrace software. The PCB layout, you can go in the units and you can convert it into inch, mil or millimeter. Now in most of the tutorials where you have seen the PCB designing, they go and make first the circuit and then they go for the PCB layout. However, I found this method much more easier than that one. So for this purpose, first of all we have to make the layout according to the LTS25NP. So here it is written, it is a pad, so we will place a pad here. And if you see the data sheet, we have four different angles of LEM25 LTS25NP transducer. The first one on the top is the bottom view, right beneath it is the back view, then its right view, and on the extreme right side we have the front view. So the dimensions are in millimeter. So first of all I will be making the pad adjustment for pin number 1, 2, 3 and 4, 5, 6. Now as you can see here in pin number 1, 2, 3, the distance between these three pins is given in the back view, which is the diagram on the left bottom side. So it is seen, it is 2.54 millimeter. So it is a standard size and you can see it is available in 2.54 millimeter. So I will place one pad here. Now this dot means that the distance between the two dots is 2.54 millimeter. So I will place three pads here. And then the next thing is, if you consider that this is 1, 2 and 3 pin, then we have to go for pin number 4, 5 and 6. So for that 4, 5, 6 we should know what is the distance between these two pins. So the distance between these two pin is shown in the diagram, which is in the middle, in the bottom side, and in the middle one, which is the right view. In some data sheets it is not written, but if you download some other data sheets, there are different versions, it is written that we have to see the right view. Now in the right view you can see here that the distance between the pin number 1, 2, 3 and 4, 5, 6 is 12.7 millimeter. Now if we divide 12.7 millimeter, because this 12.7 is not available here, so if we divide 12.7 millimeter by 2.54 millimeter, we will get exactly 5 dots. So 1, 2, 3, 4 and 5 dot, and here we will place these three. So it will give us the traces for pin number 4, 5, 6 and 1, 2, 3. Now we have to adjust the pins for the output 0 volt, which is the ground, and for 5 volt. But for that we should precisely know the distance between those pins with these dots. So if you see the back view of the data sheet, you can see that the distance between this pin and the start of those three pins is 7.62 millimeter. Now if you divide 7.62 millimeter, now the problem is, if you consider it here, it is nowhere on the dots, therefore it is difficult to adjust it properly. So we will stay on this 2.54 and we will see that the 7.62 millimeter, if we divide it by 2.54, it is exactly 3 dots. So the first dot is 1, 2 and 3 dots here. Now in this line, in this line we have to place our pin number 1, pin number output pin 0 volt and the 5 volt. So for that, now we are at this spot here. Let us mark it here. Now we have to decide the distance between these two pins. It is given in right view that the distance between these three pads, and I'm not talking about the vertical distance, it is approximately 3.81 millimeter. Now if I am here, if I have just placed this dot here, if I divide 3.81 with 2.54, it do not give me an exact value. It is 1.5. So what I will do is this: I will make 2.74, and now I am here. So now if I divide 3.81 millimeter with 1.27 millimeter, I will get 3 values here. So if I go 1, 2 and 3 here, I put a dot here. Now let me remove this dot because this was just for the marking here. Now this is, since this is exactly the half of it, therefore for every 2 dots I need, because the distance between plus 0 and out pins is 2.54 millimeter, which is exactly the double of this 1.27 scale. Therefore every 2 dots I am going to place this thing here. Now this makes my hole, and now I will group it, and if you print it, it will give you exactly the same values as the dimensions given here. You will put your transducer on your print. If you print it or 100% get the file from the printer, it will exactly be like this. Now the second thing is, I have actually I have saved it in my library here. If I place it here, it is, you can see here, it is there is some problem here. We have not made this exactly here. So let us first of all ungroup it. Okay, so for this view, let me have this one available, then I have to ungroup it, and for the ungrouping, just a minute. Okay, this is not exactly here, it should be somewhere inside, 2 pins inside. So now I think it will be exactly the same one. I have made some small mistake. Now you can see here, this is exactly the one that I have made. Now this is our LTS 25 NP sensor. Now we have to mark different things. So for this, there is written place text ABC. I will place it as, I will place a text O, which stands for the output, and let me have this thing a little bit small. This will give us a nice marking here inside it. This is O, and this is the control V, and this is the plus 5 volt. So I will make it plus 5, and the center one is, obviously I know this is the ground pin. And for this pin, if you can see, we need to know the top view. So beside plus 5 volt, we have pin number 1. So I will be having a marking here that this is pin number. Okay, pin number, this is 1. Let us make it again 2.54. 2.54. Yeah, this is pin number 1. Okay, control V, and the above one, this is pin number 6. This will be exactly pin number 6. So I'll be renaming it as pin number 6, and this is 1, 2, 3, and this is 4, 5, 6. So let me have this one also. This is pin number 4, so that we get proper labeling over it. 1, control C, control V. This is pin number 3. Okay, now that we have made all this thing, we can group it, and control A, and we can group them together. I don't know what is the issue now. It is not grouping them. Okay, there is control plus G is the group. So now that we have this LTS 25 NP, we can use it. Now the second thing we need is a TO220 package, 7805. Now this 7805 can be easily available if you search it out. I have searched it is in this Atmel. Here it is 7805. Now if you click on this, the package is written, it is TO220. So I will use this TO220 package. So for this purpose I will just place it here, and then also I am going to use some connectors. For the typical connectors I have explained their dimensions and their type in my blog post. So it is a typical 5.0 millimeter connector. So I have adjusted the entire system on 5 millimeter, and I will place a pad here and here. So this gives me that 2-pin connector. Let me call this one as the plus 5 volt, and this is the biasing supply. So it is VCC, and in my terminology, because I need to know which pin is positive, which pin is negative, there are two ways. You can either have this positive sign on the right side and the negative sign on the left side, and then you can simply click on the space button to rotate them. This is the one way. Another way is that you click on this pad, go to the pad properties, go to this pad and make it a rectangle. So you can make all the rectangle equal to positive and all the the round one equal to the negative. Whatever you like is you can use a terminology. Now I will be copying this thing, and here is my input. Because I need a wire that will go through this LTS 25 NP, I need an input which I call, this is I in, and I call it like this. This is positive and this is negative. Let me change this one to the oval one, because I am using these other topology. This is my self-made topologies. You can have your own algorithm or own protocol for designing these things. Now we have this plus, and this is I in, this is VCC. Now I need to have another one for I output, because definitely I need some output. The wire which is going in through the LTS 25 NP will go somewhere on the out. So I need another one. So this is here. Let me call it I out, I in, and this is I out. And then we need a connector to have connection for the output of this transducer. So I'm taking the output on this side, so that this is my arrangement. Actually you can make your own arrangement. So this is, I called it iSense or iSense. Okay, this is okay. I called it iSense, and I make it like this. Now our circuit is okay. Now if you can go to the LTS 25 NP MOS current transducer, you can see there is a table given on the last page which shows that according to the primary nominal current, you can adjust the connections for these pins 1, 2, 3 and pin number 4, 5, 6. Now my advice is that instead of having the fixed configuration in which, for example, for 25 ampere current you short them and that's it, my advice is to get these connections somewhere outside on the board, so that later we can configure our sensor according to our requirement. If it is 25 volt, you can short them. If it is plus 12 volt, you can connect pin number 6 and 5 and 3 together and pin number 1 and 2 together. Or if it is plus minus 8 ampere, the nominal current, you can have connection between only pin number 6 and 2 and pin number 5 and 3. So for this value, first of all, I will be having 6 pads here. Let us make it here 1, 2, 3. Sorry, we don't need this one. This is the tracing. Okay, we need 3 pads here, 1, 2, 3, and make it 1, 2, 3 pins here. Now what I am going to do, I'm not going for this rat line. Instead I advise you, because this is my experience, we will go for the manual routing. I will click on it, click on this pin number 1, and I will place this thing here. So this will become our pin number 1. Let me zoom in this further, because there is this one symbol here which I want to remove that one. Okay, so I can have my wire, I can play it anyhow, no problem. Okay, so this is pin number 1. Then I want to have this pin number 2 here, and pin number 3 you can connect it here. and then sorry, and that's it. And for this one I also need to designate them. This is pin number 1. Let me, okay, sorry, double click here, click on ABC, double click here, and you can get one here. Then press enter, go to this and just little bit decrease its size a little bit. Okay, and let us call it here. This is still very big, so let me have it on 2.54 scale. Let me small it a little bit. This is pin number 1. I'm going to copy this one, Control C and Control V, and then Control C and Control V, and I will designate them. Right click on here, click here, and make it pin number 2. Make this value pin number 3, and Control V again. I will designate this value as pin number Control C, Control V. First of all, let me make it, and Control V, and we have these values also available here. This, let's make it pin number 6. Let us call this pin number 5. So in this way, I mean, if you configure it, you can later on you can change your circuit accordingly. Now we have to connect this pin number 6. If I go here, let me route it because this is an art, you can make it beautiful as you like. And then we want to have this pin number 5 connected here, and pin number 4 connected here. So now that we have configured our sensors, this is our let us call it 7805, and let me call it 7805. This 7805 has 3 inputs. I can ungroup this component because I don't need these green lines here. And if I remove this one, I don't need this thing here. Now positive VCC should go to this side, and the negative should be connected here, and the output comes from here. So here I will reconfigure it as positive, and here I will reconfigure it as negative. Now this pin is positive, so I will route this wire, clicking it here, and it goes exactly here. And this wire which starts from this ground pin here. Now the output of this sensor come from this 0, and the center pin is grounded, so I have to connect this pin with this one, or I can directly connect it here, but let us make it here. This is the output of the regulator, which is 5 volts, so I will connect it with this 5 volt, and this output is going to the just a minute, let me come, and this output is going to the output of the LTS 25 NP sensor. Now in this thing I can reconfigure this value as well to minus, let us make it plus, and I can connect it here. Okay, so, and the second one is this ground pin that I can connect it at this point. And the third thing is we need an input that will go through this one. So for this input I will be placing a pad here and a pad at this output. That's it. Since we have we are only available with the standard 5mm connector, so I will short them. I will make them connection here. I will short both of these and connect them here as well, and here as well. Now that our circuit is okay, we have to see what is the this is, we don't need plus and negative. This is I output, and that one is the I input. The other thing we need to know before printing this circuit and trying to implement it is the trace width. Now as you can see, these are very small, so when you will print it, I have used this thing, it gives me very small holes that when printed gives me a lot of trouble before drilling and other stuff. So I am going to select these pads, right? I'm going to select these pads. Just a minute before this thing, let us make it like this. Okay, so I'm going to click here. We will go to the pad properties, and I will make it, instead of 1.5 I will make it let us suppose 2.5, and the height is 2.5, shape round, everything, right? So it gives me this value. Apply, if I apply on all pads, it will be applied on just a minute again, 1 2 3. I will have to select these pads. Okay, just a minute. I have to because you have to play a lot before, you know, having hands on with this software. So let us select all these pads so that we don't need to do it over and over for each and every pad. Click on these all 3 pads. Okay, 1. Okay, now we have selected all the pads. Go to the pad properties, make them instead 2.5, make it on 2.5 and click it. Now if you can see here, these are fine, but in this 7805 we are very near, so it will make a problem for us if we are going for a chemical etching method. So I will click here. First of all, this is my pin number 1, so I'm not going to have it in the oval form. I will make it a rectangle. Instead of this, I will make it 2.25 millimeter pad, and when I click, it gives me okay, this is good. And then these 2 are also here, pad properties, and this is make it 2.25, make it 2.25, right? And this is it. Also here they are very close, so I am going to make all of them for with a pad spacing of 2.25 you know, pad width and height. So now it gives me a very nice, you know, look over it. We can just, you know, route these wires accordingly to have some more beauty in our circuit. And the second thing is here we can, you know, we can just have it a little bit, you know. Okay, now as you can see, everything else is good. It's going well. So now we have to see if we can bring some sort of beauty in it. These texts are very, you know, big size. You can click on it and you can reduce their font size and other stuff, make it 8 or whatever it is. You can play a lot with the software. Now that our circuit is okay, what else is required? There is nothing else is required. So now for this circuit, let us click on the, there is an option that tells you the, if there are any, you know, problems with the layout, which is this design check. If you click on here, you can see there are no errors found in our circuit. But before that, you can see these wires also need to have some thickness in it. It is according to the current, or normally, you know, you don't have to be very much conscious if you are using at low current, because this is just a current sensor. But again, if you are going for a chemical etching method that I am going to use, if you're not going for the laser based, you know, PCB machine drilling and other stuff, so you have to make them a little bit more thick. So if you click on them, if you click all the wires here, let me select these wires. You can adjust the width of these wires as well, and this is what I will do now. This is just because it gives us more, you know, reliable results when we etched it according to the using the method of the ferric chloride, and you know, that heating the toner. So right click on it, there's a trace width written here. You can go to the custom value, make it, this is 0.33, try to make it 0.99 or make it 1 millimeter, and let us see what will happen. Now the 1 millimeter gives us very good, you know, thick results, but it also demands some sort of rerouting again. That rerouting is because these two wires are very close to each other, so let us make it accordingly. We can adjust it accordingly. No, it's not a big issue. One thing here, this thing is here, this thing is here, and we have these pins are connected. So let us have this one here. We don't need to, and then we can see here that this wire is going very close to this one, so we can just we can just connect it from this end. Also we can see here this pin is going very close to this one, so we can just reroute this thing. If in case you are not able to reroute it, so you can adjust the dimensions from here, the scaling from here, and then you can adjust it later on, like we have done this. And second thing is this, that we have this 1 and 3 here. I want to have this pin number 1 symbol not here. Okay, control that. Okay, let me, okay, just a minute. Okay, right click on this one, ungroup it, and then click on this one symbol, because this might make me problematic for me. I will make it inside here and make it just a bit here. This is 0 and plus 5 volt output, and then this 6 a little bit of downward, because you can see it is giving me big jumps. So if you want to reduce the jumps, you can reduce the scale. Now you can if I just you can finally adjust it using fine tuning. So it is now going very fine. I just need 1 or 2 spaces here, and then similarly this thing I am going to use with this pin number 3. I'm going to place it here, pin number 2 here, and pin number 1 here. So again we can see before placing it, we can adjust it. We have little bit minor adjustments here like this, and we will be adjusting this 6, 5 and 4 pin number identification. This helps us in reconfiguring the sensor as explained before. Now that when you are left with all the things, we have to recheck whether we don't have any trace which is thin. Now we still have one trace which is quite thin. We need to make it at the same width. So when in my case, whenever I made these type of circuits, I short these 2 pins so that I don't need to go over and over again. So this is it. There is enough space here. This is the I output. Every other pin is available. So that's all for our PCB designing here. At this stage, the last thing we are left with is to group it, edit, group it here. So now we have one PCB available, but before going for the etching process, we have to invert this waveform. Otherwise you will be getting the results that are entirely different from what you like. It will be for the surface mounted components. Since we are not going for the surface mounted components, the ultimate thing is that we can that we have to have our system that is inverted before printing it on the PCB. So for this thing there are 2 options. You can go here in the view and you can mirror this circuit. When you will mirror it, you will see this thing, and this thing can be printed and can be directly placed over the PCB board. So that's all for this part, and then the next part we are going to discuss how we etch this thing on the PCB, and that for that you have to watch the second video. Thank you very much.